The first trillionaire there will ever be is the person who exploits the natural resources on asteroids.
Asteroids aren't just cosmic clutter. They're potential treasure chests floating in space. Scientists are discovering that these ancient rocks might be loaded with valuable metals like platinum, gold, and rare earth elements. In fact, a single near-Earth asteroid could harbor more platinum than has ever been mined on Earth. With our planet's resources dwindling and demand skyrocketing, space mining could be the bold, game-changing solution we desperately need. The technology that makes it possible. At the core of asteroid mining is a mix of innovative technology and smart engineering. Imagine synthetic aperture radar, SAR, a tool once used just for mapping Earth's surface from space, now upgraded to detect even the tiniest vibrations, down to fractions of a millimeter, on an asteroid's surface. These small signals reveal hidden pockets of valuable metal that traditional methods would miss. Now picture spacecraft built to travel huge distances, meet up with speeding asteroids, and perform precise mining in a near-weightless environment. Since heavy machines and drilling don't work in space, engineers are creating new methods like laser-assisted mining to loosen or vaporize material, and using self-operating robots that can work in harsh space conditions. With powerful propulsion systems and smart artificial intelligence guiding the way, turning rocks from space into valuable resources is becoming more than just a dream. From concept to reality, recent missions and developments. The notion of asteroid mining is not entirely new. Over the past decade, several exploratory missions have paved the way for this ambitious goal. NASA's OSIRIS-REx mission, for instance, successfully collected samples from the near-Earth asteroid Bennu, providing scientists with invaluable data about its composition. Similarly, Japan's Hayabusa 2 mission returned samples from asteroid Ryugu, further confirming that these celestial bodies contain significant amounts of valuable materials. These missions have demonstrated that reaching, sampling, and analyzing asteroids is achievable. They have also provided proof of concept for the technology needed to mine these space rocks. Building on these successes, both government space agencies and private companies are now investing in more ambitious projects. Startups are developing prototypes for mining robots and spacecraft specifically designed to extract resources and either transport them back to Earth or use them in-space manufacturing facilities. The transition from sampling to full-scale mining is a major leap, but each step brings us closer to a future where space resources play a critical role in our economy. Economic promise and financial hurdles. The potential economic impact of asteroid mining is enormous. With access to a nearly limitless supply of rare metals, industries ranging from electronics and aerospace to renewable energy could be revolutionized. For instance, platinum and rare earth elements are vital for the production of everything from catalytic converters and solar panels to cutting-edge electronic devices. As demand for these materials grows, especially in the face of rapid technological advancement, space mining offers an alternative source that could alleviate pressure on Earth's reserves. However, the economic promise of asteroid mining comes with significant financial hurdles. Developing the necessary technology and launching space missions require astronomical investments. The initial costs are high, and the timeline for a profitable return is uncertain. Investors and governments remain cautious because the venture is high risk, with success hinging on overcoming technical, logistical, and regulatory challenges. Pilot projects and demonstrative missions will be essential to prove that asteroid mining can be both safe and economically viable before it attracts the large-scale funding needed to launch full operations. Alongside technological and economic challenges, asteroid mining raises a host of legal, ethical, and environmental questions. One of the primary issues is ownership. Under current international space treaties, no nation can claim sovereignty over celestial bodies, yet companies are already staking claims to potential mining sites. This legal gray area requires updated global regulations to clearly define property rights and ensure that space resources benefit all of humanity, rather than just a few entities. Ethical considerations also come into play. For example, how do we balance the drive for economic gain with the need to preserve space as a shared resource? The potential for conflict over valuable extraterrestrial resources necessitates a cooperative approach between nations, private enterprises, and international organizations. Environmental concerns, too, cannot be overlooked. While asteroid mining might reduce the environmental strain on Earth by providing an alternative to terrestrial mining, it could also have unforeseen sad consequences. Altering an asteroid's structure, for instance, might produce debris that could pose hazards to other spacecraft or even impact Earth's orbit. Careful planning and responsible management are essential to minimize any negative impacts on the delicate balance of our space environment. The politics of space mining. Who gets the cosmic share? At the core of the issue is the current international legal framework. The Outer Space Treaty of 1967, which most nations have signed, states that space is the province of all mankind, and that no country can claim sovereignty over celestial bodies. Yet, as private companies and technologically advanced nations push to extract resources from asteroids, there's growing concern over how to interpret this rule. Who will benefit from space mining? The countries that hold vast mineral wealth, or those with the technology to reach and extract these resources? Some experts worry that space mining could deepen global inequalities. Wealthy, technologically advanced nations might secure exclusive access to space resources, leaving developing nations that are rich in minerals on Earth at a disadvantage. Others argue that by opening up a new frontier of resources, space mining could drive global economic growth and provide a more level playing field, if international laws and regulations evolve to ensure fair distribution. Adding to the complexity is the emerging role of private companies. As commercial entities invest billions into space exploration, they are challenging traditional notions of resource ownership and profit. This shift could spark heated debates over regulation, with policymakers tasked with balancing the need for innovation with the need to protect global interests. Moreover, environmental concerns, both on Earth and in space, are part of the conversation. Responsible space mining must consider the long-term impacts on the space environment, including the potential for orbital debris and disruption of delicate celestial ecosystems. The politics of space mining is still in its infancy, with discussions taking place at international forums and within national governments. What's clear is that as humanity moves closer to mining the cosmos, a new era of policymaking will be required, one that navigates the fine line between fostering technological innovation and ensuring that space remains a resource for all. In the coming years, these debates will shape not only the future of space exploration, but also the broader global economic landscape. The challenge lies in crafting regulations that promote fairness, protect the environment, and encourage collaboration among nations and private companies alike. A tall order for any generation. The road ahead, collaboration and future prospects. Despite the many challenges, the momentum behind asteroid mining is undeniable. International collaboration is key to making this vision a reality. Governments, space agencies, and private companies are increasingly pooling their resources and expertise to tackle the complex issues involved in mining space resources. In the coming decades, we might see the development of orbital refineries, facilities in space that process raw materials, along with in-space manufacturing units that use these resources to build satellites, spacecraft, and other infrastructure without the need to transport everything back to Earth. The next generation of missions will likely focus on refining extraction techniques, improving autonomous operations, and establishing reliable logistics for transporting materials across space. With advancements in robotics, propulsion, and materials science accelerating, the timeline for a viable asteroid mining operation may be shorter than many expect. These projects could herald a new era of economic growth, technological innovation, and human expansion into deep space. Final thoughts. The concept of mining metals from space is as exciting as it is challenging. It represents a bold step into the unknown, where the frontiers of science, technology, and human ambition converge. While many questions remain regarding feasibility, profitability, and the legal framework needed to govern space resources, the potential rewards are too significant to ignore. Asteroid mining has the power to not only supply the raw materials necessary for the next wave of technological innovation, but also to fundamentally change our relationship with the cosmos. If we can overcome the hurdles, this new frontier could transform the global economy and mark the beginning of an interplanetary age of resource extraction. Stay tuned as researchers, engineers, and policymakers work together to turn this science fiction vision into a cornerstone of tomorrow's economy. The adventure is just beginning, and the potential of asteroid mining may one day change the way we live, work, and explore the universe.